Welcome to Olympiad Math for Year 3. This is Lesson 18, we'll learn shortest route problem. When you travel from one place to another, there are often multiple paths to choose from. The task of selecting the shortest path among them is known as the shortest route problem. To solve the shortest route problem, keep the following points in mind. First, the shortest distance between 2 points is a straight line. Second, avoid backtracking and unnecessary repetition. There may be only one shortest route, or multiple shortest routes. Possible paths can be arranged systematically in a logical order. The labeling method can be used with diagrams to ensure all routes are considered without omission or duplication, while also meeting any specific conditions given in the problem. Example 1. Suppose there is a straight road AB, and on the same side of the road, there are two villages, X and Y, as shown in the diagram below. A bus stop needs to be built somewhere on the road so that the total walking distance from both villages to the bus stop is minimized. Where should the bus stop be located? If village X and village Y were on opposite sides of the road, the bus stop should be placed at point C, since the shortest distance between 2 points is a straight line. However, since both villages are on the same side of the road, how should we determine the best location for the bus stop? We can apply a reflection method. Imagine moving village X or village Y to the other side of the road while keeping its perpendicular distance to the road unchanged. This creates a reflected point X', as shown in the diagram below. The total distance from village X to point P and from village Y to point P is the same as the distance from X' to point P and Y to point P. Therefore, the bus stop should be placed at point C, where the straight line path is minimized. To determine the shortest route, a line segment diagram can be used as a visual aid. Example 2. As shown in the right diagram, Liam and Noah start at the same time and travel at the same speed. Who will reach the school first? Since Liam and Noah start at the same time and move at the same speed, we only need to compare the number of grid steps each one takes from the starting point to the school. The one with the shorter path arrives first. Based on the diagram, Noah reaches the school first. For this type of problem, the solution is straightforward. Simply compare the distances to determine the shortest route. Example 3. There are 4 different routes from point A to point C. Which route is the longest? Which is the shortest? Among these routes, the direct path AC is the shortest, as it reaches the destination in a straight line. The other routes involve traveling along two sides of a triangle, which means their total length is greater than AC. The longest routes are AEC and ABC. This problem illustrates an important geometric principle: the sum of any two sides of a triangle is always greater than the third side. Example 4. The line segments in the diagram represent all the possible streets Ming can take from home to school. Ming only walks east or south because he does not want to take unnecessary detours. How many different routes can he take from home to school? For clarity, we assign letters to each intersection point. Starting from Ming's home, we proceed step by step. There is only one way to reach points A, B, C, and D along straight paths, so we label them with 1. To reach point E, Ming can either go through A or D, giving us 1 plus 1 equals 2 routes. To reach point F, he can come from B or E, leading to 1 plus 2 equals 3 routes. Continuing this pattern, we systematically add up the possible routes at each intersection. By following this approach, we determine that there are 13 different routes from Ming's home to the school. Here are the practice problems for today. The answer keys will be shown in 5 seconds. Please pause the video and try to complete them first. Thank you for watching and hope you enjoy your math today.